Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nur Hanisah binti Nur AZMI with student number 2019287494. In this video, I will explaining experiment T2, which is Boyle's Law. So, the first part of this experiment is the objective of the experiment. The objective of the experiment is to determine the relationship between the pressure and volume of a gas with fixed mass at constant pressure. Next is the apparatus of this experiment. The apparatus of this experiment is apparatus of experiment on properties of fluid. So, I will be explaining part by part from part number 1 to part number 24. So, the first part is the valve BV102. The second part is valve BV101. Third, filler opening AV102. Fourth, pressuring cylinder T102. 5. Globe valve GV101. The sixth one is drain valve BV104. The seventh one is the compressor. Number 8 is the pressure sensor. Number 9 is the pressure release valve, maximum equal to 3 bar. Number 10 is the vacuum hand pump. Number 11 is the pressure sensor. Number 12 is the pressure relief valve, maximum 3 bar. Number 13 is the temperature sensor. Number 14 is the measuring cylinder T101. Number 15 is the control panel. Number 16 is the pressure indicator PT101. Number 17 is the temperature indicator TT101. The 18th part is the pressure indicator PT102. Number 19 is the flow rate indicator. Number 20 is the compressor on or off switch. Number 21 is the main on or off switch. Number 22 is the emergency stop button. Number 23 is the drain valve BV103. And the last one, which is number 24, is the flow meter. Next, I will be explaining the procedure part by part from startup process to the shutdown process. So first one is the startup procedure. So first, connect the equipment to the power supply. Next, perform a quick inspection to make sure that the equipment is in proper working condition. Next, ensure that all valves are initially closed and the main switch and air compressor P101 switch are turned off. The fourth one, switch on the main power supply, the PT101, PT102 and TT101 display should lit up. The equipment now is ready for use. The next one is the procedure for experiment A, which is compression of gas. So first, perform the startup procedure. Next, fully open the valve BV101. The third step is record the initial pressure reading on PT101, volume and temperature of air in T101. Next, switch on the air compressor. When the pressure in T102 reaches 0.8 bar, switch off P101 and close valve BV101. Next, slowly open the valve GV101. Ensure that the temperature reading on TT101 does not change as the volume of A changes. Close GV101 when the oil level reaches 2400 milliliter. Wait for the pressure reading on TT101 does not change as the volume of the air changes. Repeat step number 6 and 7 for 2400, 2300, 2200, 2100, 2000, 1900, 1800 ml. Record all pressure and volume measurement accordingly using table number 2. Next, perform the shutdown procedure. Next, I will be explaining procedure for experiment B, which is expansion of gas. First, perform startup procedures. After that, fully open valve BV102. Next, record the initial pressure reading on PT101 volume and temperature of the air in T101. Fully open GV101. Next, operate the vacuum hand pump P102 until the volume of air reaches 2600 milliliter. Ensure that the temperature reading on TT101 does not change as the volume of the air changes. Next, wait for the pressure reading on PT101 to stabilize. Record the reading together with the temperature of the air TT101. Repeat step 5 and 6 for 2700, 2800, 2900, 3000, 3100 and 3200 milliliter. Record all pressure and volume measurement accordingly using table number 3. Perform the shutdown procedure. This is the last part for the procedure, which is the shutdown process. So, first one, ensure the pump switch is turned off and all valves are closed. Next, fully open GV101. After that, if the tank is under pressure, open BV102 and GV101. Operate vacuum hand pump P102 until both tanks reach 0 bar. Close all valves. If the tanks are under vacuum, both BV101 and GV101 need to be open. Switch on P101 until both tanks reach 0 bar. Switch off P101 and close all valves. Switch off the main power supply. The next part of this experiment is the safety part. So, the first safety is to make sure all the power supply cable is connected properly. The second one, make sure the condition of the apparatus is checked before the experiment begins so that the apparatus can operate properly. The third one is make sure that the ice level is parallel with the indicator when taking the measurement data of the experiment so that parallax error can be avoided. The next part of this experiment is the conclusion. So, in conclusion, this Boyle's Law experiment has achieved its objective, which is to determine the relationship between the pressure and the volume of a gas with fixed mass at constant pressure. Furthermore, all the data needed from the experiment, such as theoretical value for pressure in experiment A and experiment B, are obtained from the experiment and required calculations. Based on the data obtained, set of graphs which are pressure P against volume V for both experimental and theoretical are determined. Overall, the experiment can be considered a success. The next part for the experiment is the recommendation. So the first recommendation for this experiment is try to not exceed the maximum pressure that has been recommended during experimenting. The second one is try to not making mistakes while taking the reading of the measurement for the experiment result data so that the experimental data is legit and correct. The last part for the experiment is application. So the first application of this experiment that we can see in real life is the bicycle tire. When you pump air into a tire, the gas molecule inside the tire can compress and pack closer together. This increases the pressure of the gas and it starts to push against the walls of the tire. You can feel how the tire becomes pressurized and tighter. The second application of this Boyle's Law in real life is soda bottle. To get carbon dioxide gas into the liquid, the whole bottle is usually pressurized with gas. As long as the bottle is closed, it is very hard to squeeze, as the gas is confined to a small space and pushed against the bottle's walls. When you remove the cap, however, the available volume increases and some of the gas escapes. At the same time, its pressure decreases. That's all from me. Thank you.